जी मैम आप नहीं पूछिए.
Okay, Deepan, I will ask one question from algebra.
Yes.
You have a group S3 direction S3, or you can say
S3.
sorry, not direction S3 product with S3 S3 Cartesian product of groups. I am talking about uh,
Yes.
okay S3 cross S3. Okay,
Mm.
so can you give me one cyclic subgroup of order 6 in this group,
Mm.
or it will not exist?
It will not exist because subgroup of a cyclic group should be cyclic, but S3
But
is
is
not
it
cyclic.
but S3 cross S3 is it cyclic?
S3 cross S. Mm, no, it is not cyclic, I think, because it is not. I mean, abelian. I mean, direct product of true. No, from this S3 cross S3 is not. I mean, not cyclic. Yeah.
Okay, so what I have asked you to give me a cyclic subgroup of
Okay,
S3
okay.
cross S3.
We can take S3 cross S3. So order 6, right?
Right.
Mm,
You can use pen and paper if you want.
okay, I'm thinking. Uh, cyclic. So we can take identity cross S3.
Okay. So
I mean, identity is the element from the S3 cross
hmm.
S3. So it will the order 6, and in fact it is normal surface of S3 cross S3.
Oh, and it is cyclic.
No, it is not normal though, but uh, identity cross S3 it is 6, and mm, no, see, order 6 is not may not be cyclic. Okay, okay, I am changing my decision.
Okay, so Deepan, let's move to the next question. I think.
I mean, I have to use I mean pen and paper so that
I'm saying that you should use that, but you
I
are
mean
not.
it will take more time. I think.
But
I didn't. Yes,
time.
sir. Yes, sir.
Oh,
Sorry.
okay. So moving to the next question. If you
Okay,
have
okay.
two groups,
Hmm.
first is 2Z group
Okay.
under addition 2Z.
Yes.
Okay. And the
Hmm.
second group is 3Z.
Okay.
So are these two groups isomorphic?
No
Okay. What is the problem?
problem. I mean, 2Z. I mean that uh, 2 belongs to 2Z. I mean, if we expand that terms of 2Z,
Hmm.
I mean that, but 2 doesn't belongs to that set 3Z. I mean,
Okay. For a isomorphism, is it necessary that both the groups should be same?
not, but the element of that element. I mean, whatever the generated. I mean, sorry, that group generated by the elements of two groups should be. I mean, same.
No. Okay. Fine. So
Okay.
that's okay.
But
Okay. I got your answer. Thank you.
okay.
And next question is if you have a q root 2, okay,
Sorry.
so I'm saying you have a 1 minute. Let me. You,
Cube root 2.
yeah, q
So
root q. We are adjoining square root of 2 with rationals. Okay, like we have polynomial rings
okay,
over
okay.
rational.
Mm-hmm.
Instead of x, we have
Yes,
q.
yes, understood.
So if you have q square root 2 and other is
Yes,
q square root 3, are these two
yes.
both of
Mm.
them are vector space over q, right?
Yes,
So as a
yes, yes.
vector space, are these isomorphic?
Yes, as a vector space, this is isomorphic.
How?
we can define the mat. Suppose phi such that q root 2 to q root 3 defined by phi of a plus b root 2 a plus b root 2 equal to a plus b root 3, where a b belongs to q, and this is I mean from a vector space condition, so it is isomorphic with the vector space relation,
So
but it is yes.
if I say that you have to use dimension argument, can you say something in terms of
Yes,
dimension?
both the q root 2 and q root 3, so dimension is 2. I mean, so I mean the dimension of q root 2 over q and the dimension of q root 3 over 3 is 2, so their isomorphism.
Okay. And q root 2 is a ring, right?
Yes,
And similarly q root 3.
yes.
Okay, so as a ring, are these isomorphic?
No, as a ring, this is not isomorphic.
So there is the problem.
Yes, yes. Problem is we can take. Can I use pen and paper?
Yeah,
Just
yeah, sure,
1 minute.
sure.
Okay. Is it visible?
Yeah, it's
I mean,
You
I
have
am
to.
saying.
Yeah, yeah, no
I mean,
problem. You write
I
and
I
then say.
am saying. Okay, okay. That's fine.
Take your time. No problem.
Yes, yes, yes. So I am taking the map phi such that q root 2 to q root 3 by phi of root 2 which maps to root 3. Okay. Now we know root 2 whole square equal to 2. Then I am since it is a ring homomorphism, so we can apply phi. So phi of root 2 square equal to phi of 2, and which is 2, and phi of root 2 square equal to, we can take phi of root 2 whole square, and by the property of ring homomorphism, then phi of root 2 square equal to, this is root 3 whole square, so this is 3 equal to sorry, 3 equal to 2 comes, which is a contradiction.
Okay. I just a minute. I think you are in the right direction, but why phi of 2 is 2?
Yes, because this is continuous, and we can I mean I only hold
Why it
homomorphism.
is continuous?
I mean on I mean I have to say one word, that that identity homomorphism is the only I mean
How you can
sorry,
define identity homomorphism here?
here phi of 2 equal to, I mean it maps identity to identity by the property
What
of
is
ring
identity?
homomorphism.
Oh,
Huh?
identity of q root 2 you are talking.
Yes, yes.
Okay.
It is, I mean, if it is satisfy ring homomorphism, then it should map the identity element of q root 2 to identity element of q root 3.
So what is the identity element in q root 2?
And this is 1. I mean, q root 2 is the polynomial ring which is generated by, I mean, what is it? I mean,
Q root 2?
generated by root 2.
Q root 2 is a polynomial ring.
No, I am not saying. I mean, generated by root 2. There, with the
Okay.
rational.
Okay,
Q
Deepan. Okay, I think you can do it, but you think after some time. Okay. So I'll
root
move to
2.
my
You
next
are saying.
question.
So, okay.
Yeah. So
Okay.
can we have a surjective ring homomorphism from zx to z direction z2? You write first thing. First space is
ZX.
zx to z direction z2.
ZX is
Yeah,
polynomial ring.
polynomial ring over z. And
Okay.
the others.
to
Z direction Z2.
Z direction Z2. So question is there
Is
on to?
huh. Just for simplicity, you remove X from the first side. Just use. Can you define surjective homomorphism from Z to instead of ZX, you write Z only.
Okay.
Hmm. Do you understand my question?
Yes, 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 yes.
Okay. Can we have a surjective group homomorphism from Z to Z to Z direction Z?
Yeah, I can. 5x minus 2 y bar 0 0. So yes, we can define. I think
Okay, great. Can you give me?
phi of x. I mean x belongs to z, which is maps to x comma 0.
Okay.
So
So, are you saying that it is a surjective group homomorphism? How you will get the pre-image of 0, comma 1?
0 comma 1.
It may exist or it may not.
For this group, I mean homomorphism.
Not for this, I am talking in general that can there be any surjective group homomorphism
Hmm.
from starting from Z to
Hmm.
Z direction Z2?
Hmm.
You can use, if possible, fundamental theorem of isomorphism.
Okay, I understand. Z comma 2 Z. Z2 and uh, yes, if it is kernel is I mean Z mod 2Z, which is isomorphic to Z2. So sorry, Z plus.
Can you state isomorphism theorem? First isomorphism theorem.
Yes, let G be a group mm, and G dash be suppose the G dash be another group and a mapping F such that G to and G to G dash is a map, and then by the first
Just map.
fundamental.
Just a map.
Uh,
It is just a map or
if
something.
it I am not taking first of all here onto here, and if you take onto, then I mean, but
Is it a set map or is it something more than that?
yes, it is a set map obviously. So then kernel F which is isomorphic to f of z dash.
Can you repeat? I not understood.
Hello.
Your voice is breaking.
So suppose G and G dash be two groups and F such that G to G dash be a
Yes, yes,
hello.
please.
And F such that G to G dash be a map. I mean the set map. Then by the first fundamental theorem we can say G mod I'm as if I am as I mean I am assuming it is an onto. Then G by kernel of F is isomorphic to f of G, which is isomorphic to Z dash. So this is the first fundamental theorem.
What what do we mean by G by kernel of F in this sense? Because you are not taking here group homomorphism. So kernel F may not
It
be
is
a
a
normal group in that case. So
yes, it is a quotient.
how can we take quotient if the F is not a group homomorphism? You are just taking a set map, right?
Yes.
You are not taking group homomorphism.
Now, yes, first of all, it is a homomorphism. I am just saying that because kernel of f is always a normal subgroup to the domain group G. I mean, I am assuming f such that G2 G dash is a group homomorphism.
Okay.
Hmm.
Okay, so can you give me a class equation of Z6?
Hmm. Z2 cross Z3, we can take the partition of.
I am asking about class equation.
I didn't understand. Please repeat.
Can you give me the class equation of Z6, abelian group Z6? Do you know class equation?
You are saying that the form of that class equation.
Huh? Do you know what is class equation?
Yes.
So, can you give me that form?
Okay. See,
Okay, Deepan. So,
yeah.
you think about it after some time. I just want to ask my last question and then I'll hand over to Tushar. Okay. So, can we have a non-abelian group of order p square where p is a prime, odd prime? So, I'll repeat my question. Can we
No.
have can we have a non-abelian group of order p square where p is any odd prime?
No. Any prime power order non-abelian group.
Yeah.
No, it is not exist.
Why?
If order of G equal to p square, okay. Uh, mm, then I mean I'm using that Silo's third theorem. Okay.
Okay.
For the prime p, then one by the okay.
What is Silo's third theorem?
If np for the prime p and if np equal to 1 plus pk where p is a prime, and then if it is divides I mean if np equal to 1, then it is a normal subgroup, and np if np divides that order of the group, suppose here it is p square, and if np equal to 1, then
How?
it is a unique subgroup.
So how does it help you to conclude that there may not exist any non-abelian group of order p square?
Okay, that I am thinking. So this gets up.
Tushar, we have time or not?
No, ma'am.
So we can use Lagrange theorem also.
Okay, so how you can conclude from Lagrange theorem?
I mean,
Okay, so firstly state Lagrange theorem. What is Lagrange theorem?
let G be a let G be a finite group and H be a subgroup of G. Then by Lagrange theorem, order of that order of H will always order of H divides order of G.
Okay.
So this.
So how does it help you in concluding that there cannot be non-abelian group?
Yes, if order of I mean here order of G equal to p square prime power square. So the only possibility of that sorry.
No, you
So only
you
okay.
continue.
So only possibility that that subgroup is 1 p or p square. Okay. And if it is 1, then it is always I mean divide that group, and it will no, sorry, if I am first take prime, so if prime power order is always cyclic, so and cyclic group is abelian, so
So
from that,
one minute. What you said?
yes,
Can you repeat?
if it is prime, I mean
Uh,
if prime divides that order p square,
hmm.
so if order of g is equal to prime, then it is prime power, it is abelian, I mean it is cyclic. By this Lagrange theorem we can say.
Hmm.
Okay, so from that, I mean I think, and cyclic group is abelian, we know. So and you are saying that I mean you are asking about non-abelian group.
So what you are searching through Lagrange theorem and what we need? You just think what is the relation between what you are searching and what I am asking. You think just for a while and tell me.